Ladies and gents, welcome to the Thursday Wits Geotalk online. Thank you all for joining us. We've already got a pretty big audience, 30 people watching here on Zoom and a few people watching on YouTube already as well. And I see Mike has joined us as well, which is fantastic. Thank you, Mike. You dropped off for a moment there, so I'm glad you're back in the Zoom.
I'm back in.
That's wonderful. So welcome everybody, and of course thank you to John Hancock's and the CCIC group for sponsoring these online talks. It's really appreciated, and as you can see from the introductory slides, we have a few great talks coming up over the next few weeks, so we hope to see you every week. And of course, if you want to be added to the mailing list for these talks, just pop me an email, and it's a fairly instantaneous thing. So let me then start off by introducing Mike de Wit, who's joining us and very kindly offered to give this talk today. He studied his honours degree at Trinity College in Dublin in 1975, and then came out to South Africa to work at the Geological Survey, as well as do his MSc. And thereafter, he spent a very long career working in De Beers and Anglo-American group, working on many different geological deposits throughout Africa, and finished off his consulting career, I guess, working for Sedilo Resources from 2009. And currently, he is privately consulting and is also an honorary professor at the University of Pretoria up until 2018, and is now a research fellow at the University of Stellenbosch. So, Mike, thank you so much for joining us. And I'm going to stop my screen share, and you will be able to start your screen share. Fantastic. I can see your PowerPoint, and we just need to get it into full screen mode. There we go. All right, Mike, over to you. Thank you so much, and we look forward to hearing about this very interesting topic. Thank you. Mike, you just need to unmute. You are muted.
Hang on. Yeah.
There we go.
Okay.
We can hear you now. Perfect.
Yeah. Well, good afternoon, everyone. Great to be able to give this talk this afternoon. It's a subject that I've been very interested in for a long period of time, and some issues will be a bit of a repeat on some issues that we've discussed before. But we are taking this further, this project. So hopefully, I can be able to share that with you. If I may just go to the next slide. Want to do that. Sorry. I don't know, just a second. I don't seem to be able to move the slides.
I think it's because the laser pointer is on, Mike. You could just try use your arrow on your keyboard, or you could just click on the next button there on the bottom left-hand side.
There we go. Okay. Can you see that on the next slide?
Yep, perfect.
Good. Maybe just to kick off here, a slide of the main alluvial deposits in South Africa in white dots, and some of the major kimberlite mines in purple. And it's interesting to note that most of your alluvial deposits that we have in South Africa occur off the Karoo bedrock, as we see in the diagram at the bottom right. But the area of interest is really the area in the block in white. There are substantial alluvial deposits in what was referred to as the old Western Transvaal and the old Southwestern Transvaal, now part of the Northwest Province, which really have no known primary sources associated with them. So it's always been an enigma, and it's still at the moment, as we speak, an area of great interest from an exploration point of view, particularly for finding a primary deposit. Just looking at these deposits in two ways. Firstly, in terms of the number of carats that have been mined on the left, one can see that around Lichtenburg, with the L here, it's been an area that's produced most of the diamonds in the Northwest Province, probably about 10 million carats in the order of. and an additional 2.5 to 3 million from Ventersdorp area. And then there's also a substantial area between Schweizer Reneke, Bloemhof and Christiane and Wolmaransstad that have produced something in the order of 2.5 million carats. These are estimates because some of the early production records are not always available. But if you compare those, the total of some, say, 17 to 20 million carats that have come out of this area, which is probably about 2.5% of the total production of South Africa. So it's a reasonable amount of diamonds. And if you compare that to the value of those diamonds per carat, which is expressed always in US dollars per carat, the value of the diamonds around Lichtenburg is probably the lowest of those three areas. It's at the moment probably around $200 a carat, if that much. Ventersdorp diamonds are substantially better quality, so they're estimated to be around $450 a carat. But the best quality diamonds occur in the southwest, around Schweizer Reneke, in the order of $500 to $600 a carat. So there's three areas that are different in production and also very much different in value. The first diamonds in the Lichtenburg area were discovered in 1926. They occur in what we call diamond runs and sinkholes, which we'll discuss a little later. And as mentioned, the total production is in the order of about 17 million of those three areas. There is actually a heritage site at the first discovery of the diamonds in Lichtenburg, which was in a cattle dip that was dug by the local farmers in that time. If one looks at the geographical distribution of those diamond runs, and there's a photograph of one of those runs from the air, there's a whole number of these runs that occur from between Lichtenburg and Mafeking, almost to the Botswana border, right across to almost Randfontein. This is a distance of about 150 kilometers. They occur on a high-lying area, which is being referred to by some of the people that work on the Dwyka has been referred to as the Cargonian Highland. And just to illustrate you the elevation differences, a north-south orientated section from north to south, going from the Bushveld Basin quite steeply up onto the Dolomites and onto the Pretoria's group sediments, then down slope down onto the Black Reef and the Ventersdorp lavas at a lower elevation. So that gives you an idea of the geomorphological setting of these diamond runs. They all occur on this higher elevated area. There have been various models and various ideas of how these runs, what they are and what have produced them, what age they are. It's still something that is not entirely nailed down, but I think we're getting a much better idea on the depositional environment. But the main thrust has always been south-flowing Paleo river systems, probably of tertiary, I guess Cenozoic age, and maybe even of Pleistocene age. And there are various people who have described these, and it's kind of difficult to explain that if you have big, large rivers sitting right on the high topographical areas. But we'll get to that in a short while. Just as a background to geology, as I mentioned, the Ventersdorp lava at the base, that's the Neo-Archean rocks. They are overlain here by the Malmani dolomites with a very thin sequence of the Black Reef. But the Malmani dolomites of Chert-Poor and Chur-Rich zones overlay that, and that's overlain by the Paleoproterozoic Pretoria group, quartzites and Hackport volcanics, etc., to the north. And there are bits and pieces, small bits and pieces of Karoo. Here's one near Lichtenburg, L for Lichtenburg, V for Ventersdorp. There's a bigger patch of Karoo sitting between Schweizer Reneke and Wolmaransstad. But in between here, there are several people have mapped bits of small outlayers of Dwyka and Eka sediments, particularly here near Ventersdorp. There's some Eka in some of the sinkholes preserved. So there's Karoo around in most of these areas. Just as a matter of interest for the Malmani dolomites on which these gravels are associated, is a sequence of these dolomites. The dolomites have some very abundant chert bands in them, very hard and resistant to weathering. So whilst the dolomites are being dissolved in the weathering profile, you are left with a residue of chert rubble that is incorporated into these sediments that overlay these dolomites. Dolomites also have some spectacular stromatolites and is quite famous for that in that area. If we now look at a bit of an oblique view from south to north of that paleo high, you have an area where the Malmani dolomites occur, which is on which most of these gravel runs that we're going to be talking about occur. It's overlain by the Pretoria series group, but in between, at the base of the Pretoria group, is a thing called the Rooihoogte Formation. It's a chert-rich breccia in places. To the north, there are some more conglomeratic facies, but it's a chert-rich breccia that has been produced by a time gap that exists between the Malmani and the Pretoria group of about 80 million years, in which you had paleokarst forming and already a weathering surface that has been expressed by these very hard silicious Rooihoogte breccias. So that's a major unconformity that exists between the Malmani and Pretoria on which these gravel runs occur. Just south of Lichtenburg, there are some very nice glaciated bedrock, roche-moutonnées and striated pavements. Near Ventersdorp, we can see polished surfaces with percussion and cheddar marks, all very much reminiscent of the Dwyka glaciation, which shows a very clear ice flow direction to the southwest. On top of this surface, in addition, we can see upper Karoo or Triassic cross-bedded sandstones that are preserved in some of the sinkholes on the dolomites. These are in places pebbly with beautiful polished chert and quartz veins. Local diggers call these silkies, and they're quite fond of getting them in their concentrate. And this is very much similar to the upper Karoo sequences that we see in eastern Botswana and northwest South Africa. In addition, there are some sinkholes that have or depressions that are filled with lower Karoo shales, and here you can see some Glossoropterus leaves in some of those shales that occur near Rydal and Ventersdorp. And then recent drilling has intersected substantial thicknesses of Dwyka just outside Lichtenburg. So the dolomites are intimately related to the preservation of some of the Dwyka that occurs on that same erosion surface that was produced by on the Malmani dolomites. We also see some deep areas with deep lateritic weathering and manganese wad, some kaolinized sandstones and conglomerates with some plant thresh in them. And this is interpreted as the post-Karoo African erosion surface. So what we really have here is a very large area that has been subjected to various periods of erosion or but it has seen very much has been an unconformity over this very length of time. If you look at some of the apatite Fission track dates that tells you how much erosion has taken place, and these are particularly intense on the margins of South Africa. But certainly in the central part, and including on the Dolomites of the Northwest Province, the ages are fairly old, which really means that very little erosion has taken place in recent times. And most of the erosion has really, in this part of the world, has taken place between 400 and 300 million years. So we have a very stable area that has been exposed for different times, an old land surface, a palimpsest landscape that has seen enormous gaps in time and has been preserved as such. In yellow, I just show you here some of the Karoo that has been preserved on that same surface with the diamond runs as they occur over there. Okay, so let's have a look at these diamond runs. They're sitting on this whole surface. There's an aerial shot of one of them. Generally, certainly in the Lichtenburg area, they are slightly elevated. They can be wide between 50 and 300 meters. They can be fairly long. They can be up to 35 kilometers long. They tend to occur on this flat dolomite and form these positive ridges. In the Ventersdorp area, they're more incised into the dolomite bedrock, but are similarly in shape and in form. If you look at some of the gradients of these runs, it's quite interesting to see that some of these runs actually go generally almost on a flat surface, but in some cases they go uphill in a downstream direction, and we know that the direction comes from the north based on the clasts that occur in these gravels that are mainly Pretoria quartzites, or predominantly Pretoria quartzites, and so there's quite a bit of topography over these runs. So that's very difficult to explain that in terms of fluvial model. We therefore believe that these things are probably more related to the Dwyka and maybe eskers that were sitting underneath the ice. With water pressure under ice, one can move eskers in uphill and downslope directions. If you look at the gravels themselves, and perhaps the first one is the left top slide here, there you can see the DMM, that's the basal part of some of those gravels. They almost grade into a brecciated bedrock of mainly chert rubble. That's all from the local dolomites. Here in the photograph on the right, some of this bedrock has been folded. And also grades into some of these diamictites, these very coarse, poorly sorted gravels, of which these runs are composed of. And also there are some very interesting shattered and fractured bedrock, which almost looks like frost shattering. So the interpretation of these is that this is bedrock that was sitting underneath these eskers. And was tectonized in a glacial environment. The gravels themselves are extremely poorly sorted. They contain a lot of angular fragments, particularly of chert, some dolomite, not a lot of dolomite. They contain some very interesting, very rounded pebbles of quartzite, chert, quartz. And also contain agate populations. There are two main agate populations, in which we'll get back to in a minute. And of course, then there are the diamonds. So what we have here is eskers that formed in the Dwyka that contain diamonds. This is a photograph of one of these outcrops in the Ventersdorp area with very large foresets. And it almost looks like a fluvial glacial deltaic sequence at the end of one of these eskers. If you look at some of the clasts, these are quartzite clasts, and some of these are Roy Hocht conglomerate clasts, you can see the amount of percussion and the amount of class-to-class interaction that has taken place in these eskers. These were really very violently flowing systems, not something that you would expect on this fairly flat surface on a fluvial system, but really something that's on the ice, that's under pressure, a lot of banging and smashing into each other. The matrix is, as I mentioned before, poorly sorted, in places class supported, in places matrix supported, and it does contain some isolated foreign exotic class. Some of those are the agates, and there are two population of agates in the Lichtenburg area. You have the rounded class here. Sorry, can I just move that? You see the rounded class that are predominantly come out of the Hekpoort. There are some jaspers, there are some quartz, some other agates, and these are the sub-rounded agates. There's a whole population, only particularly in Lichtenburg and in some of the potholes and the runs, that are composed of subangular agates that have tubes that haven't really been moved. So you have these two sets of agates, and we believe that these unabraded agates have come out of the bushy bent volcanics, which are sporadically occurring volcanics, amygdaloidal volcanics, close, very just above the Rooihoogte. They occur quite a lot around Potchefstroom. They occur in East Botswana. So we believe that these also occurred in the Lichtenburg area and have, due to erosion, just left behind their agate population. This is just a stratigraphic column, again, to highlight the importance of that unconformity between the Malmani subgroup and the Pretoria group, and on which these gravels have been deposited. In some areas there are some very weathered clays, red clays, in which these unabraded agates occur, and chemistry, particularly some XRD analysis of these clays have suggested that they're the result of weathering of basaltic rock. So these are highly likely being the remnants of these bushy bent volcanics. If you then just produce a Mickey Mouse diagram of this palimpsest landscape, you have the unconformity between the Malmani and the Pretorias, on which the gravel runs occur. You've got remnants of Karoo sitting here. You've got Rooihoogte bridges, as well as bushy bent volcanics. And at the same time, this has been highly altered parts of it have been highly altered in the African surface weathering phase. So that's the sort of scenario. We've looked at lots of zircons from various samples and sites. And there are two types of zircons. There are the what we believe are mental zircons. They came up with an age of about 500 to 600 million years. And then there are the crustal zircons. And all of these show ages well beyond 500 million years, and predominantly actually more beyond 1,000 million years. So there are no young, there's no evidence of any young volcanics or young activity in this area. In addition, we've managed to get a couple of diamonds with diamond inclusions, and these are very useful for dating not only the growth of the diamond, the origin of the diamond, but also when the diamond was exposed to surface, i.e. when the kimberlite that contained the diamond erupted. And this has shown that both these two inclusions have given an age of between 500 and 600 million years, during which the kimberlites were intruded. And this falls within the age brackets of many known diamond-bearing kimberlites in South Africa, such as Venetia, the Oaks, River Ranch, and others. So it is fairly likely that these diamonds have also been recovered or have come from kimberlites of that age. So if in summary for the Lichtenburg area is we have this the runs occur on this very flat surface. We got gradients that go uphill. We've got gravels associated with tectonized bedrock bridges, sediments that are diamictites, they're poorly sorted, and sedimentary facies that conform with glacial fluvial glacial deposits. There are no young zircons, and the diamond inclusions suggest that the diamonds have come from 500 million year old kimberlites. We've seen no fossils. There's reports of some fossil wood, Karoo wood. We certainly have found one piece of Karoo wood in one of the sinkholes, and therefore the original deposits of these runs are believed to be proximal escus that got deposited during the final stages of the glacial Dwyka glaciation. So taking that now a little bit further, sorry, before I do that, I've just did a comparison to some areas around Estonia, and the distribution of these escas is very similar to the Quaternary glaciation that we see in Northern Europe. Also the facies they're very similar type of gravels. They got the same sort of sorting, matrix and class supported, angular and subangular class, etc. So it's quite a model that seems to fit what we see today and in other parts of the world. Some of the diamonds, these are diamonds that have come from the Lichtenburg area. And the first impression that you get is that this is a fairly colored and almost black. There is a lot of bort in here. So this is not a great quality diamonds. As you can remember from the first slide, the values of this area is pretty low. And one can see that immediately in this population. If you look at towards Ventersdorp, this is I think this is the Manana run. There are some diamonds in there that are much better quality. There's a beautiful lime yellow diamond that was found in east of Lichtenburg. There's another much better quality diamond from the same area. And I want you to remember this color because we're going to come across it a little later. It shows that the areas to the east of Lichtenburg produces a different type of diamond. This is a photograph that Tony Marshall took from a population of diamonds from Tirisano, which is in Ventersdorp. And the impression is that the quality is a drastic improvement of what we see. Sorry, Grant, is this thing at the top, is that on the screen?
No, Mike, I don't think so. We can just see your screen here. There's nothing else.
That's fine. No, that's something. Okay, the quality of the diamonds in Ventersdorp is obviously a lot better. And if you then look at that, it is a bit of a busy slide. But there's Lichtenburg and there's Ventersdorp over there. These are the Bakerville diggings where we find a lot of diamonds, but much poorer quality than around Ventersdorp. This is a set of diamonds, and don't think they're very big because there's the bar scale here. That's millimeters. This is from an area down in the Bakerville side. You get some cubes, you get ballas, you get bort. These diamonds have shown no region features. There are no green spots, and there are an abundance of fragile stones here. This particular deposit that was mined has also produced enormous amounts of kimberlitic indicator minerals. And the suggestion is that you had some primary dikes, primary kimberlites here, producing these 500 million year diamonds. So those would be more local diamonds. But in the Ventersdorp and also in the Lichtenburg area, you get a different population of much better quality diamonds, where we don't really know the source of. And these are probably more distally derived. It's also an area where we only see the Hekpoort agates. In this Lichtenburg area, we see the Hekpoort and the Bushy Bend agates in the deposit. So there are some differences. The belief is that we have primary sources for some of the diamonds here, the poor quality diamonds, but we still are looking for the sources of the much better quality diamonds that occur right across this area. Okay, so let's take this a little bit further now. So we have the Lichtenburg area, and if we now take ourselves back in time and we look at, first of all, let's look at what Visser used to call the Cargonian Highland, which was the highland from which the ice pack, on which the big ice pack developed and from which the ice flowed both in the Kalahari Basin and into the Karoo Basin. So if we take it into the Permian, the sort of the last stages of the glaciation, these eskers were moving to the south and southwest towards the Schweizer Reneke area. So let's have a look at that Schweizer Reneke area. And just as a matter of interest, the diamonds in Schweizer Reneke were found quite a bit earlier than those in Lichtenburg in 1906, but mining started a little later. And in this whole area between Schweizer and Wolmaransstad, it's estimated that it had produced in the order of 4 to 5 million carats. The diamonds are very much better quality, 85% gem quality, and today's prices, well, yesterday's prices, 2019, are sitting around $1,000 a carat, with an average size close to a carat per stone. So a very different kettle of fish, a lot better quality. If you go back to this topo map, Pretoria already recognized in 1910 that these valleys, these major valleys, were glacial valleys. And I mentioned already that there is quite a lot of spread of glacial or Dwyka sediments, weathered Dwyka sediments, thin Dwyka and Eka sediments in this whole region. And that has been documented by von Gutberg, who did quite a substantial mapping exercise in this part of the world. And that's the well-known Karoo outlier here between Schweizer Reneke and Wolmaransstad. Again, the geology here, there's the outlier of the Dwyka, of the Dwyka and Eka sediments. You've got the Krypon to the west, and you've got the Dominion belt to the east. So also with the rest under cover of your Ventersdorp lava. So what we have is a pre-Karoo high, and with what we think is looking, what it looks like is that we have a glacial outwash plain consists of a thin layer of tillites that we mapped in this area, and with what Peter Bosch described as paleo-kettle structures, some of the pans. But more importantly, we get the edge of the Eka marine sediments that occur along this Cargonian highland at the end of the Dwyka glaciation. So we have this very thin but widespread Dwyka sediments, and this is a trench where they're trenching the upper gravel, very thin gravel, but the bedrock is all Dwyka sediments. So you have a thin gravel and then a soil on top of that. These are vast expanses of this Dwyka, and interestingly enough, you get the same type of, you get lots of chert clasts, but also quartzite clasts that are highly percussion scarred, very similar to what we've seen in Lichtenburg. We get some quasi-porphyries. We get the quartzites, the cherts. We get some bushveld granites. We get agates, some red jaspers, all stuff that has moved from north to south, sitting in the Dwyka, and that is now being and in the gravels overlying the Dwyka. However, some of these sediments are sands with interbedded gravel lenses, and these are being believed that these are weathered Eka sequences from the marine incursion of the Eka Basin, and you get these beautiful little gravel units, also gravel lenses, which occur mainly between the 350 and 1400 contours, which is interesting enough that here's one of these pans that have been interpreted as a paleo kettle. But if you look at the distribution, there's Schweizer Reneke, there's Wolmaransstad, north is there, so the eskers would have come from the north. These dots are all recoveries of diamonds, and the more colorful dots are higher in production, but they all occur along this contour line of this finger that extended from the Cogonian highland. And if one can put that in a probably better graphical map, that's the sort of 370 to 380 contour line on which a lot of the diamonds have been recovered. These are some higher grade mines and reworked into in lower grade deposits. But please note the presence of these deposits right along that contour line. And if you look at the diamonds themselves in that area, you can see this is a 4.5 carat stone, but you can see the amount of abrasion that occurred on this stone. It's been hammered. For diamonds to be abraded needs quite some doing. So here's another example of a 3 carat diamond. Look at the abrasion on that. That thing has been really hammered in this marine environment. And again, look at this, the abrasion of this diamond. But look at the color of this diamond. There's again this lime green diamond that we see in Lichtenburg. These diamonds have come all this way and moved into this marine environment in which they got highly abraded. So if we look at some of these other Eka heavy mineral deposits, you've got the heavy mineral deposit at Bothaville, at Delmas, at Carolina, and at Newton. In fact, there's some gold associated with these. These are all Eka shoreline heavy mineral deposits that you can trace along the old Eka shoreline on which this Schweizer Reneke area is part. So there's the Bothaville heavy mineral deposits sitting there. You can see these are beautiful ridges, beach ridges that are sitting at the same elevation as the diamonds that occur along that ridge of Schweizer Reneke. And if you look at what Vos and Hopte have said about these Bothaville heavy mineral deposits, they see some high energy swash action, some pebble lenses, beautiful cross-bedded. We see that at Schweizer Reneke as well. So that is a bit of description of what the shoreline was doing. There was quite a lot of activity. It was low tidal, but a lot of wave action. Another study done by Mike Brennan shows you the orientation of these shoreline deposits from Delmas up to Bothaville. So, and these facies are attributed to storm-influenced sedimentation and record the dominance of wave-dominated microtidal coastline. So we're sitting with our diamond deposits in that wave-dominated microtidal coastline. And there's a bit of a sketch, and as you can see, this is work in progress that John Ward and Pierre Diaga and myself are busy with. We're looking at the intertidal area. This is north, that's south. So we've got the Dwyka and we've got the Eka coming up against this topo high with some Tambola platform deposits at the back of it. And if you look at a profile from Lichtenburg area down here, where the eskers are sitting, we're going down into a fairly flat area here where a lot of the Dwyka is just sitting here as remnants, and then getting up to the Eka shoreline. This is the Eka basin coming in here quite steeply and knocking on this shoreline, knocking about these diamonds into these paleo shoreline facies. So in terms of where the diamonds are sitting, we got this what we so far refer to as the deflation gravels, outwash plain gravels. We got the regolith gravel, which are gravels from the Eka that have been lateralized in places. They're found along this contour zone of the Cogonian Highland. In many places, these quartz-rich sandy gravels are very similar to these heavy mineral beach deposits that we see at Bothaville. These have been reworked, and the ages of that is still not entirely clear, but they've certainly been worked into some of those runs that come off the Schweizer area, the London, the Zeven, the Zuidpam, Bamboespoort, etc. Certainly some of those are younger deposits, but some of those may well be reworked glacial outwash streams. We still got to get to grips with that. We certainly see that these are the sort of grades that one can get in those deposits, and the reworked deposits having a slightly better grade. So the sort of preliminary findings of this study shows that we've got this regolith gravel sitting at that elevation. They grade from gravel into quartz-rich sandy gravel deposits, which is really to do with your marine setting. It correlates very much to the Eka heavy mineral beach deposits in Bothaville and others. And they sort of divided into three facets. You've got a storm-influenced lower shore, you've got an upper shore, and a microtidal beach. So we see these things, as a final comment here is that the dolerite intrusion, there are some dolerite intrusions in this in the Clarkstorp-Wolmaransstad area that intrude totally unabraded or totally weathered Dwyka, which looks like which doesn't look like Dwyka, but it shows you how weathered this Dwyka can be in this northwest province. So as a sort of preliminary preliminary results, we have Lichtenburg diamonds around Lichtenburg of 500 million year poor quality proximal diamonds. We got Lichtenburg Ventersdorp diamonds in the whole area, Lichtenburg and Ventersdorp. They're better quality, more distally derived diamonds. We know of kimberlites of 500 million years and older. The Botswana Lorala pipes, the Cullinan, Venetia. So there is 500 million years is not out of the basket in terms of finding kimberlites that age. Diamonds were transported probably by pre-Karoo fluvial systems. There must have been some action before the Dwyka came in. The Dwyka ecosystem took a lot of these diamonds and from the pre-Karoo kimberlites and moved them in the Karoo Basin. These glacial sediments were reworked in low intertidal marine processes, Eka processes, and formed these deposits down at Schweizer Reneke. And there are these beach deposits have concentrations of heavy minerals, garnets, ilmenites, but also diamonds. We see these heavy minerals, they've been described by people in Bothaville, Caroline, and Delmas, and also in Muden. So the Eka marine depositional environment is very similar to what we see on the Schweizer Reneke and down at shoreline. So we have, and then subsequently we have some reworking by deflation and fluvial activity in post-Karoo times. So that would be an interesting model. what I want to finish off with is a slide showing you some diamonds that an area that I mapped between Kimberley and the Vaal River. It's where Kimberley diamonds washed down to the Vaal and got mixed up with Vaal River gravel. And the population of diamonds is very interesting there. You have unabraded, typically Kimberley yellowish diamonds. They're typical Kimberley diamonds, but there's also a population of highly abraded diamonds. And these, no doubt, in my view, have come from reworking of these Eka diamonds that have come from the Eskas from Lichtenburg, and they got reworked into the Paleo-Vaal River and got stuck into some of the terraces that we see downstream along the Vaal and the Orange. So these diamonds have really been recycled through many cycles from the 500 million year kimberlites right down to almost the Quaternary. So that's that's an interesting model, but we have to now think about there are good signs that we've got primary sources around Lichtenburg, but what about these diamonds, these better quality diamonds from Ventersdorp and Lichtenburg? And that's still an interesting question that we're going to have to think about very carefully. So I think that's all I have to say there, Grant.
Mike, thank you so much. That was incredibly informative, and I certainly really enjoyed it. And by looking at the number of questions that I see coming up, I think the audience enjoyed it too. So if you could just leave your slides up, because there may be some questions that relate to some of those slides. Just to remind the audience that if you do want to ask a question, there's many ways you can do it. You can write into the Q&A box, and you can also just click on the raise hand button, and then I can unmute you and you can talk. So I think I see a bunch of written questions, and I'm going to start with Sue, who asked the question, Mike, are there enough data to map the uplift as the ice sheet retreats?
No, I don't think we do. I don't think we don't have any good feel for that. I think the problem really is also dating the various interglacial periods at the end of the Dwyka, and we really don't have a good handle on that at all. So I'm sorry to disappoint you, but I don't think I can answer that actually.
Okay.
So it's fine. It'll be fine tuning that. I think with time, maybe we should be able to, and particularly looking at some of the Dwyka sections that have been drilled around the Lichtenburg area. Detailed work of that still has to be undertaken, and I think there may be some answers that could be coming out of that.
Okay, and then there's a question here from Roger Gibson, who says, I'm interested in the tectonized bedrock. Is this related to glacier movement, or is it crustal deformation and stress?
Yeah, I think it's to do with the movement of the ice over the bedrock. The bedrock is, it's undergone substantial weathering prior to Dwyka, so you have loose. Well, you've got weathered bedrock, and as the ice scours over that, it starts tectonizing some of that bedrock. So that's how I interpret that, and I've seen examples of that in other parts of the world.
Okay, great. Roger, I hope that answers your question. I see Sharad, your hand was up. I'm going to ask you to unmute and go ahead.
Hi, can you hear me?
Yes, go for it.
Yeah, I can hear you now.
Hey, hi. I just have a question about the Cargonian Highlands that you mentioned from Fission. Where did you get that name from? It always puzzled me.
That is a good question, actually. It sounds almost Scottish to me. To be honest, I don't know where he. Yeah, I do remember reading it somewhere, but it's sitting in the back of my filing cabinet in my head, and I just can't retrieve it at the moment. So I don't know, but I'll get back to that one.
Okay, thanks.
Thank you, Sharad. I also have a question from George Henry, who says, has fresh kimberlite been found in the Lichtenburg area?
The answer is no. it's the only evidence that we have for kimberlites is that I was involved with a little project with some diggers who were on digging on a gravity and magnetic target. They got substantial diamonds and also an abundance of unabraded indicator minerals such as garnets and ilmenites. And that is as far as we've seen evidence for primary kimberlite. Now you must remember that these kimberlites are sitting in a waterlogged dolomites, and I don't think that particular kimberlite will last very long in that sort of environment where weathering and particularly underwater will effectively break down these ultrabasic rocks quite quickly. There are various other places we've seen similar sort of evidence of abundant diamonds with indicators and fresh indicator surfaces, slightly different chemistries. So the interpretation, and also with geophysical signatures. So the interpretation is really that we have had a few, there are certainly two that we know of, 3 or 4 places where there is strong evidence of primary deposits there. But having seen any fresh kimberlite, the answer is no.
Okay, do we have any other questions from the audience? Feel free to raise your hand.
There's a few questions here from Pretoria.
Yeah, so Mike, would you like to handle those ones?
Well, I see that was the abrasion caused by other diamonds during transport? That's always a good question. Is do we see diamond on diamond percussion? I think it's difficult to say, but there's certainly some of the diggers that I spoke to on one of the runs where there is an enormous amount of plasts that are highly percussioned, and they mentioned that they see a lot of broken stones in that particular run. So I think there's good evidence to suggest that there is a lot of bashing around, particularly with pebbles on diamonds, that these diamonds get abraded and broken in places.
Okay, and then I see Ray has posted a question there. I believe that the state and Council for Geoscience are making efforts to encourage artisanal and small-scale mining. How is that progressing? Do you know?
I don't know. I'm not really in contact with a lot with the Council of Geoscience. I don't know. You'd have to ask the people at the Council of Geoscience.
And then perhaps we just take 1 or 2 more questions from Johan Smith. The first one: how does the diamond abrasion you mentioned compare to the West Coast marine stones?
Well, we also see abrasion of stones on the West Coast. It's a percentage. Obviously, interestingly enough, you do get some unabraded diamonds on the West Coast, and the diamonds move. Sometimes you have these flash floods in the orange, so diamonds move in a more matrix-supported media and get protected. So not all diamonds get abraded, but you certainly do have a higher percentage of abrasion on the West Coast, and we see that also in the Schweizer. I think the figure I have in mind in Schweizer areas is about 15% of the diamonds show abrasion features, which is quite high actually.
And then a question from Karen Smith, who's watching: has FTIR been done on the yellow and orange diamonds? The color and cubo-octahedral morphology of one of the orange ones suggests they could contain isolated nitrogen.
That is quite correct. We did some work on a population of stones from Lichtenburg, and certainly isolated nitrogen was suggested. So yeah, the diamonds I showed you, the yellow, pale yellow diamonds I showed you, have not been done. They had already been on the sale by the time we could try and do some work on them. Okay,
fantastic. I see George Henry has his hand up. So George, I'll give you the floor and ask you to unmute.
Hello, Mike. Thanks for a great talk. Just one interesting question. has anybody found any diamonds in the Dwyka tillite itself?
Well, if the ESCA model is correct, then yes, diamonds have been found in large quantities in the Dwyka, and it's difficult to say whether no diamonds have been found. A lot of diggers that I know have dug into the Dwyka, thinking it's original. Certainly outside the Lichtenburg, I'm thinking it's alluvial gravel, and reported diamonds. Whether they have come out of there is difficult to say. I think one has to do a fairly qualitative exercise to establish that. But I have no doubt that these deposits in Lichtenburg are part of the Dwyka. So the answer would be yes.
And Sue, come through.
Say again?
Sue has a question as well. Sue, would
Hi,
you like
Mike.
to?
It's Sue Webb.
Hi, Sue.
Hi, Mike. It's Sue Webb here. How are you?
Yes, Sue, how are you?
Can you guys hear me? Yeah.
I
All
can.
right, good. I wanted to ask how thick is the dolomite in the Lichtenburg area? Are there areas where the dolomite is thinner, where you might actually preserve fresh kimberlite under the dolomite?
Yeah, it's a good question. I don't know. I think the dolomites are fairly flat lying, so it would be I guess a irregular floor under which the dolomites sit that would change the thicknesses. I don't know of places where it's thinning and thickening. It's so far. I'd have to think about that. It's a good question.
Okay, well, thank you very much. Thank you, Mike, for taking all those questions. I think it's a sign of a very interesting and thought-provoking talk. So thank you very much for giving this talk. We really appreciate it. And what I'm going to do now very quickly is just share my screen to let you all know about next week's talk, which is a talk by Willem Kruger, and he'll be talking about his recently completed PhD work on the constraints of massive magnetites, and his work has very recently been published. The most recent work has just been published in Nature Communications, I think, on a new magmatic process called karstification in magma chambers. So that promises to be a really interesting talk. And the week after, we have a completely different talk focusing on the tectonic evolution of Venus and the implications for early Earth dynamics. So we hope that you'll be able to join us for that. And lastly, I just want to remind everyone, or do a quick advertisement for this public interest short course we are running called Exploring the Earth and Solar System. And if anyone has any family members or anyone who might be interested in doing an introductory to intermediate level course in geosciences and planetary geoscience, then please pop me an email, and we still have some capacity on this course, which is being run at the Babanango Nature Reserve towards the end of July. Right, thanks everyone. It's great seeing you all online, and we hope to see you again next week. And once again, Mike, thank you very much for joining us.
Good. Okay, good.
All right, thanks everyone. See you next week.